Thanks very much for having me here. So the phrase generative AI did not exist a year ago, I think. Now it's suddenly all the rage. So to really put things into context for what generative AI means for search and what some of the organizing principles are about when we think about this, I want to take you back to the distant past, really long time ago, to late Thanksgiving of last year, right? This is when, the bombshell literally dropped on Twitter when, they said, there's something called ChatGPT, come give it a spin, tell us what you like. 10 o'clock that morning, I think. A couple hours later, I tweeted something like this, right? I was absolutely, mind blown. And this is somebody who's actually played with systems like Lambda 2 years before that at Google. And still, it was absolutely impressive how good ChatGPT was. And I really thought that Google's supremacy for information-seeking searches, we'll talk about that soon, was suddenly threatened, I think, for the first time ever. There was a new way of doing search. There was a new paradigm in town. And I think it literally jolted us all into a lot of excitement. But having said all that, I still think that what we've witnessed so far and what we're going to, what we've been seeing in the last 4 months really is the tip of the iceberg. I think there is an amazing amount of innovation that's going to happen with respect to generative AI, the way it's used in search. And my goal here is really not so much to show you a particular system or talk about one particular idea, but to give you both the background on what, where, and how we got to where we are a little bit, and to talk about some organizing principles about how to think about search and how to think about generative AI and search together. First, let me go back and ask, why was I mind blown, right? Why do we really think it was such a big breakthrough? If you think about it, the technology was very, very evolutionary, very incremental. Transformers came out, BERT came out, other things came out. Things were growing pretty linearly, and suddenly we see that we landed at a point where even though the technology was very incremental and evolutionary, the resulting user experience was stunningly revolutionary, right? And that was one of the reasons I think it's a real breakthrough. But if you think a little harder, something else also becomes apparent, right? While the technology was incremental and evolutionary, it was also complex. But the user experience was both revolutionary and extremely simple, right? Suddenly, it's almost as if the web didn't exist and we went back to a Unix terminal where you're actually typing questions, and it's like a chat or one of those things pre-internet on Unix. It was literally text typing back and forth. It was very simple, very revolutionary, and yet it was very, very powerful and very useful when it works, right? Historically, if you think about it, search technology has had many clever breakthroughs. This is not the first breakthrough in search, right? PageRank came along, synonyms came, knowledge panels happened, knowledge graph happened. So many things happened. But with every such advance, what happened was search UI actually got more crowded. It didn't get less crowded, unlike what we're seeing today. Right? Here's an example, right? If you don't know who Greg Abbott is, it's the Texas governor about a block from here on the Texas Capitol, right? If I go to Google and type Greg Abbott, this is what I see. And everything that's in blue is a clickable unit. And there is so much information packed into this. Besides the official website for Greg Abbott, there's some top news stories, there's a Wikipedia links, everything about when he was born, where he was born, who his spouse is. There's a lot of stuff packed in there. And if I scroll down, there's even more, right? The kind of questions people have asked when they talk about Greg Abbott. Greg Abbott's Facebook page, Twitter page, the usual link set. And just in case people who are interested in Greg Abbott might also be interested in Kari Lake, for example, of Arizona, there's a link for that too, right? There's just so much because we'll talk about why in a minute. But again, continuing on Greg Abbott, there's even more. His Twitter feed, Wikipedia link, related searches, some images, all kinds of things about Greg Abbott. Right? This is all in just one page. If I take a step back and ask, what are the answers? What are the questions to which I'm given the answers here? And here's a sample of them, right? In this page, I listed out about 28 or something, and I actually ran out of patience. There's just 50 or so questions for which the answers are here. Everything from, when was he born, where was he born, whose spouse is, how many children does he have, why is he on a wheelchair, number of questions related very finely, very precisely to Greg Abbott, but also in the broader context of Greg Abbott, Texas governorship, and so on. So this web search result page has the answers to so many questions about Greg Abbott. And you might wonder, why? Right? Why has the UI gotten so complex over the years? Why are we getting so many pieces of information thrown at us in one shot? The answer is actually very, very simple, right? It's simply because search engines could never fathom what is the exact intent with which you went and typed Greg Abbott. And of course, it's a loop, right? As you start getting results about Greg Abbott's birthplace and his spouse, you're not going to go and type Greg Abbott's spouse, right? You're going to type Greg Abbott and you know where to look. So we are in this feedback loop with Google and Bing and other search engines, which has resulted in the situation where search engines don't know exactly why we type a certain string. In particular, search engines don't know our intent. Therefore, they optimize for what seems natural, which is the fewest keystrokes to get you to the answer that you care about. It could be a click, or it could be a piece of information directly on there. And sometimes the number is actually 0, right? If I really wanted to know where Greg Abbott was born, I don't need to type anything more than Greg Abbott. Odds are I might even get it with just Abbott, right? The information is there if I know where to look. So because search engines could not fathom the search intent, the intent behind the strings that the user typed, they've gone into this position of creating a huge overload of information, and the UI actually reflects that, right? And that's the way things have been evolving, and which is why I think ChatGPT highlights one of the amazing things that large language models can do for us. Large language models, never mind large language models, natural language allows you to cut through all the clutter. You can actually, if only search engines work perfectly with natural language, you could actually say exactly what you want. If you're looking for Greg Abbott's birthplace, you could say where was Greg Abbott born, and you'll get the answer. And you do get the answer for that, right? But that's one of the most amazing things about natural language. It lets you say what you want, and if search engines are good enough to handle that, you will get exactly what you're looking for. And that's one of the things that ChatGPT placed front and center, right? Because the experience was that of a chat. You go and type. You don't go and type Greg Abbott into ChatGPT. You actually say why you are thinking about Greg Abbott, or what exactly it is that you want to know about Greg Abbott, right? So the slight change in the UI paradigm unlocked this or unblocked our way of thinking from keywords to stating our intent, which is, if you think about it, that's the whole point of a search. The search is really you have some underlying intent or a goal that you want to satisfy, and the point of going to search engine is really to do that. And by that little shift in the UI, setting your expectation to ask what you want, using natural language, ChatGPT has opened our eyes to this idea that natural language processing is so good, we could actually put it to real work instead of cluttering a UI with lots and lots of relevant but not needed details. Of course, that comes with a huge responsibility, right? The moment you open up this kind of expectation, people are going to ask all kinds of things, right? You're going to type maybe your life story and ask things, right? For example, you're going to go and ask things like, do I need Apache Beam if I'm going to use data flow on Google Cloud, right? This kind of question is something that you'd phrase if you expect the search engine to understand what it is that you want, and to have the ability to hone in and pull the right kind of information for you, right? So this contract between users and search engines has been revised in a very intriguing way, and that is with the ability to comprehend what the user is saying and get the right amount of information in the right way with the right summaries or other forms, expectations are now set extremely high, right? So that's the outcome of this two-way contract being changed ever so slightly. Fortunately, of course, we know that large language models are actually a two-way street, right? And this is something that I think is less appreciated in most of the wisdom that you see on the internet. And by this I mean two things, right? Everybody, of course, raves about how GPT-3 can write the Gettysburg Address in the form of a rap, right? That's totally fun. We all love it, right? But we are awed by its abilities with respect to its output. But what is subtly getting hidden is the fact that it's actually amazingly good at processing what it is that you asked it in the first place, right? That means that in the context of search, language models allow us to become really expressive, ask exactly what it is that we want. And the synthesis part is nice, right? The summarization is nice. By now, I think we're all probably tired of ChatGPT telling us paragraph 1, paragraph 2, overall, blah, 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 right? There's that structure that's almost evolved there, which is nice, which is wonderful. But the less appreciated part, in my opinion, is that it allows users to ask questions very naturally in ways that are very awkward to do on, say, Google searches. So to sum it all up, I'll say this, right? So far, what's happened in the last 4 months, which is kind of mind-boggling if you think about it. 4 months is really, we've been told there's a new paradigm for searching on the internet, for knowledge on the internet. Don't search with keywords, ask what you want, right? So that's kind of nice and clear at this point. But the more important question, of course, is what does it mean for the future? Is it really game over? And I'm sure you agree with me when I say, it's not even the beginning. And in fact, I alluded to this. This is just the starting point. There's a long way to go. Let's first start by looking at what I think are the most common and maybe even easy arguments against generative AI in search, right? The first, and I think the well-understood part, is really that the fluency in language that comes from large language models often mask inaccuracies, factual inaccuracies when you do search with LLMs. So what does it mean? Here's before I get to an example, a very quick overview of what an LLM is. Again, I'm assuming every one of you knows it, but I'll say it, right? LLM is a great next word predictor. You could get technical and talk about tokens, but think of it as a next word predictor, statistical next word predictor, right? And the thing I'll say is that when the statistically most likely sequence of next words happens to be the right answer, they look magical, right? If I go to LLMs and ask, what are the movies for which Jennifer Lawrence won an Oscar award, it's going to nail it. It's going to tell you exactly what the movies are, mainly because the training data for GPT-3 or BARD consists of lots and lots of web pages that talk about Jennifer Lawrence, the movies that she won an Oscar for, and all of that, right? So you're going to get that. And it's doing it purely statistically. It's not like your query was perfectly understood and decomposed into the units and the entities and all of that. None of that, right? It's really the statistically most, if it's almost like saying Jennifer Lawrence won an Oscar for, and the next most likely sequences happen to be the right answer, and they look wonderful. And of course, when that doesn't happen, they look anywhere from crazy to maybe even dangerous. So I think today's petition for pausing AI kind of reflects the fact that things could get dangerous if LLMs don't start hallucinating, right? Here's a quick example, right? I'll let you stare at this for a moment. So I had a question about Alan Turing, right? So I wanted to know, who are the PhD students of Alan Turing? So I asked the question, and you can start with this, go do your own Google searches, and you'll soon find out that of the 5, maybe 1 or 1.5 answers are right. The others had nothing to do with Alan Turing. In fact, some of them came well after Alan Turing's time. I think Strachey maybe and others as well. Somehow, in the memory space of ChatGPT, Alan Turing, British mathematician, Christopher Strachey, computer scientist, also British, etc., came together. Somewhere something collided, and it made up a very convincing paragraph that Christopher Strachey was Alan Turing's student. And of course, like any good computer scientist, I was curious to know if Alan Turing was actually a good PhD advisor. Was he a successful PhD advisor? And now the stories get even more interesting, right? Alan Turing really cared about his students. He let them think independently, on and on and on, right? This is all lovely, fun stuff, entirely made up. And of course, if you didn't know that Alan Turing had maybe 1 or 1.5 PhD students, you would think, oh, this is awesome, right? But again, I'm not saying anything new that nobody here knows about. All of you know that this is what GPT-3 or ChatGPT does. We are aware of it. Hallucination is a well-known, well-acknowledged problem, at least, when it comes to using LLMs for search. But the less well-understood part of search, I'll say, is how do you use LLMs to build search systems, right? LLMs in their native form are really next word predictors. You could use them to answer questions by posing them as questions and looking at the statistically likely sequences of answers. But what is a search system? A search system is something that should be optimized for giving the right answer. It should be optimized for getting you complete the task that you care about. And we'll talk about what kind of tasks we care about in a moment. And let's not make any mistake. All of these are actually search systems. ChatGPT, Sydney, and Bard. Of course, GPT-3 by itself is not a search system. It's a pure LLM. But when you go from GPT-3 to ChatGPT, there is a certain kind of fine-tuning that has happened, and that is using reinforcement learning, using human feedback to produce certain kinds of behaviors. Nice words like alignment get thrown around, but ultimately what you're doing is you are fine-tuning it and taking it from a model to a system. So let's talk about how to build search systems using LLMs. But more importantly, let's actually revisit the question of what is search, right? Here's a quote. I say quote in quotes because it's not really a quote. I think Lao Tzu actually said something else that's kind of like this, but I might have asked ChatGPT to make it for me. But anyway, it's a reasonable summary of what a search is, right? The search is actually a journey. You are going towards something. It's not an end goal in itself, but it's actually a step towards something. So when you think about search, of course, you all naturally think about Google, no question about it. We think about Microsoft Bing, which is a fantastic search engine. Think about some of the new players in the market like Neeva and some of the old players in the market like DuckDuckGo. These are all perfectly good search engines. Right? You should think about them when you think about search. But don't stop there. Right? There is a lot more search happening on there, happening on the web out there that's not captured by the four examples that I mentioned. In particular, think about all these places where search happens, right? And I'm not even including ones like YouTube here, right? I partitioned them into 3 buckets based on different types of characteristics, but ultimately these are all places where a lot of search happens. And these are all places where people go to search for many, many things, right? You go to ThomasNet if you have a hydraulic press that needs a part that's missing, right? You go to StubHub if you want to buy tickets to a game at exorbitant prices. This is the kind of places where you go and search and you're finding things and you're getting things done here, right? And that, again, it touches retail, marketplaces. Clutch is a place where you can go and hire developers, right? That's, again, ultimately an intent-satisfying search experience. We can also think about the data types of 2 kinds of things. We talked about search intents earlier. I mentioned search engines. There are many different kinds of them, and I think it's worth keeping these clear in our heads. For example, there's web search, as done by Google and Bing and others. There's site search. You go to some website, there's a search box that lets you search the content of that site. You could have listing search, which is typically the kind of things I showed in the previous slide. Lots and lots of Expedias and the Airbnbs, Indeed, all of these places where there's a whole bunch of listings of many different types that you're searching through. There's enterprise search, which is a different beast where you're searching through the corpus within an organization with its own privacy controls and access controls and a bunch of things, Slack channels and whatnot. Search can be crawled like Google or Bing or hosted like Zillow or indeed, or latent in some cases. Imagine, and I don't think we've even scratched the surface of the latent part. Imagine the entire CRM database, the customer database of a company is crawled, indexed, and searchable. Right? There's a whole bunch of knowledge in there that is not visible through any search engine today, and that's actually a shame. And I think that's probably going to change soon. Search engines can be flat or sliced, like in Google, where you have images and videos and news and other things, or faceted, like you see on e-commerce sites. Search intents also come in many different shapes and sizes. There's navigational, which says, you want to go to United Airlines webpage, you go to Google, type United, it'll take you there. Chrome takes you there, actually. Informational, this is, again, a very large class of searches where you're trying to find information about some topic. Again, the information can be very coarse-grained or very short-lived, or something that's that you engage in for a very long time. It can be transactional, everything from download the latest version of DuckDB for Ubuntu Linux, right? That's a very transactional search. When you search for DuckDB for Ubuntu Linux, the underlying intent is a transaction, right? It's not just, you don't want to learn about the history of DuckDB for Ubuntu Linux. You want to actually download it and get on with your life, right? That's a different kind of search intent. Search intents also have single versus multiple outcomes. In the case of the DuckDB on Ubuntu, it's a single outcome. You're going to install it and move on. If you're applying for a job, it's a longer-lived search. It's got multiple outcomes. You might look at multiple job listings. Conversely, if a recruiter is looking for candidates, they're looking for multiple candidates, not just one. As I said, they could be short-lived or long-lived. So there is, again, the intent could be a task intent, complete something, versus browse. Browsing is a perfectly good use of search to learn about some things, learn about options, availability, and so on. So there's a whole. I'll summarize it by saying that search is a very messy and very multidimensional thing, right? And to think about LLMs in this context, how do we organize these into some basic principles so that we can actually start talking about what's the role of LLMs in these things and how LLMs could potentially change the shape of search. So I'm going to talk about two ideas. The ideas of an answer and a decision, which I think is one of the most important and valuable organizing principles to take away from here. By very coarsely and loosely placing search engines, search intents, all of them into these two types, I think we'll gain a lot of insight into what LLMs and generative AI can do for search. And the short summary for what's about to come is that pure language models are probably going to be good for an increasingly larger and larger fraction of answer searches, but they're not going to help you a whole lot with decision searches. Okay, we'll talk about them in a minute. And we'll point out one of the fundamental barriers for LLMs to solve the latter. And I'll tell you a little bit about what we're doing. Again, not meant to be an infomercial for what we're doing at our company, but I'll tell you the somewhat technical position that we've taken here. And I'll conclude with a slide where I hallucinate about what the future might bring about. So at a very, very coarse level, I want to think about search as two kinds of things happening, right? One is, think of generative AI in the context of search as an interactive Wikipedia, something that you can interact with nearly endlessly, ask fine-grained questions, focused questions, ask for clarifications, zoom in, zoom out, etc. But to a first order of approximation, think of it as an interactive Wikipedia. It's a conversation on a topic, very broad, very narrow, and it can drift as it evolves, right? I can start talking about Greg Abbott and quickly talk about gun control in California, right? It's very easy to have that kind of drift in a conversation, and that's what I call an interactive Wikipedia model for answers. The second one is what I call the decision maker model, where you are exploring options related to a goal-oriented task. You want to look through a database of listings, learn about that space of products or things, and you're going to make one or a few choices. So this is my first cut approximation of the two types of searches, and I think this dichotomy is valuable because it helps us think about what LLMs can do, what generative AI can do in a somewhat principled way between the two classes here. Again, the examples are self-explanatory. I don't need to read them out for you. In the first case, again, you can learn about very complex topics or very recent topics like the Oscars. You might explore a topic over a longer period of time. Carbon sequestration is something that you might learn for about 20 minutes, but diabetes is something that people might learn about for a much longer time. Basketball scores, again, very short-lived, small information need, right? These are all good examples of interactive Wikipedia model. The other kind is, you want to buy a hairdryer, or you're looking to apply for a job, or you're renting an apartment, or hydraulic press replacement parts, right? In all of these cases, you need to browse, you need to decide, you need to act. And this, to me, is a very important distinction, especially when it comes to the role of language models. Because the second class not only has text or text and images, but it also has a lot of structured information at various granularities, right? And the information could be very, very precise, fine-grained, saying that this is the model number for this part, as opposed to text that talks about something more qualitatively. So we know from having played with ChatGPT for 4 months or so, and Bard for 4 weeks or so, they are actually pretty good for many topics that are well represented in the training corpus, right? And we talked about how they might hallucinate for tail topics. And we do know also that fine-tuning can help significantly. By fine-tuning, I don't just mean fine-tuning on, you can fine-tune on a corpus in the data sense, take the LLM, fine-tune it for, data on everything about music or everything about politics. You're going to get a better LLM which can answer questions much better on that corpus of objects. You can inject fresh data, continue the fine-tuning so that it can answer questions about recent events. And again, this process is fine-tuning and figuring out the right objective, right? So once you keep doing that with data, it's going to get better with that corpus. You could also do instruction fine-tuning, and I think that's the other very valuable knob that LLMs have. And this is the part that I think makes it more magical. And this is not just, again, writing the Gettysburg Address in rap style, but you could actually do more interesting things with instruction fine-tuning. Again, there are subtle differences between the Flan style instruction fine-tuning on a bunch of natural language tasks, express these instructions. There's the instruct GPT kind, which is a broader set of natural language instructions, and chain of thought prompting, which is a very promising idea because you want to teach the LLM, apologies for anthropomorphizing it a little bit, but you want to teach the LLM to make at least 1 or 2 steps of reasoning here, right? All of this is reasonable in the interactive Wikipedia model because once you do a fair bit of fine-tuning of various kinds, you start seeing the so-called emergent abilities like chaining 2 steps of reasoning, occasionally 3 steps. And of course, I think I'm not even going to touch upon the question of can they do multiplication and addition and division and so on. I think that's an exercise that's not going to get us anywhere. But from the viewpoint of interactive Wikipedia style browsing of information, it is possible to fine-tune LLMs, but they will still have a lot of difficulty with very specific entities. On the other side of the story, in the decision maker model, when I went to buy a set of kitchen knives for our home, this is what the picture approximately looked like, right? I'm browsing results, opening a tab for new results, Google about something because I read a phrase there called a Santoku knife. I didn't know what a Santoku knife was, so I wanted to go learn about it. And once I knew what a Santoku knife was, I really wanted it. So I went back and started changing my search. And I wanted to be able to say things like, I want a knife set that has a tomato knife because we use a lot of tomatoes, and that has a Santoku knife because I just read about it and it seems like an awesome way to chop carrots, right? This is the pretty significant thing. And for this one kitchen knife set, I quickly realized I had 23 tabs open and shuttling between Google and the various providers. So this is how a decision maker searches with multiple intents and so on. And here, out-of-the-box language models are essentially useless, right? You could go and ask, what is a Santoku knife, and you'll get a good answer, but very micro topics start to matter. Very, very precise details start to matter. And if an LLM can't answer questions about Alan Turing's PhD students, which is a well-represented topic on the web, right? It should be easy for, not easy, I mean, it should be easier for an LLM to say, no, Alan Turing didn't have too many PhD students, right? But yet, you see that it makes up information. Fine-grained details matter. The discussion often gets into very niche vocabulary on very, very tiny little things. And more importantly, the data has structured and unstructured information, right? Part numbers, number of bedrooms in an apartment, or prerequisites for a job application. Some job might say you need 10 years of experience in C++. These kind of details are very hard to pinpoint exactly with an LLM, and that's a big challenge. And I think we're going to see a lot of both commercial as well as research innovations in this space. But more importantly, there's a fundamental reason why LLMs, I think, will struggle here, and that's the fact that they cannot ground the conversation in real-life entities. I don't want to get all philosophical and talk about sensory inputs and so on, but when an LLM talks about Alan Turing, it's talking about the string Alan Turing, which showed up as a bunch of characters. It doesn't have a real grounding of Alan Turing as the British mathematician, who helped the Allies win the World War II in a certain way, right? It doesn't have these things. It doesn't have a knowledge graph inside of it, right? Although the way the conversation looks, it looks like it understands who Alan Turing is, what he did, etc. But that grounding doesn't happen, whether intentionally or accidentally. It certainly looks accidentally like it does have a grounding of these things, but we know that that's not the case. So this is going to be a significant limiting factor on the decision maker model, where you need absolutely grounded discussions. When I say, Cuisinart coffee maker of certain type, I'm talking exactly about that. I'm not talking about anything else. I'm not talking about coffee makers in general and so on. So the inability of LLMs to ground their discussions on very concrete entities makes it even harder when you deal with things like e-commerce, because the number of entities there is very, very large and it grows very fast, right? It needs to develop an internal model of how these entities are organized according to certain facets or taxonomies and so on. So that's going to be a big challenge, and again, I hope to see lots of innovation here. Here's one of my favorite examples. If you're doing an apartment search and you say 2-bedroom San Francisco apartment within walking distance to BART, there's so much going on here, right? There are structured constraints on the number of bedrooms, there are geospatial constraints, and it assumes what we'll call a world model, right? And the idea that BART is not one entity, it represents a bunch of train stations in San Francisco, and walking distance to BART is really the disjunction of all of them, meaning that as long as I'm able to walk to a BART station, I'm happy in seeing that listing for this query. So these kind of things require lot of additional knowledge, additional world model that LLMs can't handle. And of course, it makes it even harder because at that moment in time, the database might have some things that are walkable to a BART station, some things that are not walkable to a BART station. To be able to make the distinction on the fly is a bigger challenge. So I want to talk a little bit about what then? I mean, so what? If LLMs can't do it, how are we going to solve this? And how do we put the best of generative AI to work in this decision maker experience, and how do we make it better? Here's a bit of a mock-up, right? This is, pick up your phone and start chatting like you chat with a friend, and you say, help me find an apartment in San Francisco. An ideal assistant or search engine will tell you, because this is an underspecified query, the intent space is very large, say something like, do you have specific neighborhoods or types of apartments in mind? And then the user should be able to say what, or not just what, how they think of it, right? I commute to the peninsula a lot, I want to be close to the Bay Bridge. And then The engine goes to work and finds some things for you. And it presents something in a form like this, which let's say you can scroll horizontally and save or shortlist or do a bunch of things. Then the user notices that they're looking for a 2-bedroom. That's one way to make the query more specific. So they add something there. And again, you get a bunch of results. Browse them. I click on one of them. I see something like this. I scroll down, see something more. I close this little window, go back to the search. And then I have a question about the second listing very specifically. And I ask the question, is Geneva Avenue a quiet neighborhood? Now this is where it gets very tricky, right? Because now I'm talking about a specific street in San Francisco. There's a lot of context. And I'm talking about in the context of the second listing here, which mentions Geneva Avenue. So here, again, an ideal search engine would bring results like this and continue the conversation with more questions and answers, and then maybe take one more question. And this time, actually, I wanted to answer, give me information that's very relevant to that. I said, what's the nearest BART station? Then I want the answers, not just generic answers. I want apartments annotated by their walking distance to BART station. This is what a good search experience I anticipate will look like very, very soon. If you kind of reflect on this, there are a couple of core elements here. One is that there's a seamless interleaving of results and conversations. There's a lot of other UI elements like scrolling, filtering, saving, sharing. This is, again, table stakes, right? You absolutely need them. You want rich conversations about individual results, about the categories. For example, if you're buying one of these projectors, you might want to learn about it. You might say, what are the types of projectors I can use for watching movies at home? And they come in so many price points, so you want to understand what do you get for the price points, right? Being able to research a product category is important. World knowledge becomes important. You might want to add or undo constraints. You tried something, and then you say, okay, that's good. Then you say, you know what, actually, I don't care about steel finish anymore. Give me any finish, that's okay. So this is all managing that state, accumulated preferences. All this is going to be absolutely critical in doing this. And of course, you'll need very important bells and whistles like longer lived sessions, because these things are not something that you finish in one go. Sometimes you come back to it and do things. Executable actions are going to be important. Okay, that sounds good. Book that ticket, right? You want to be able to execute that. So this is sort of the life story of a decision-making search session, if you will, and that's something that LLMs will make a big contribution to. So here I'm going to talk a little bit about our particular position and how to do this. And again, it's got a nice underlying principle. This one is actually real. It's a real code that somebody said. So I didn't, ChatGPT didn't make it up for me. So our key insight is that LLMs actually, in our stack, we use LLMs in many different places, at least 5 different places if I remember right. And one of the core use cases is these are amazing compilers. In particular, they can make beautiful language-to-language transformations. And that's something that's underutilized in the use of LLMs, right? They can write code. We know they can write code because, well, I know because I use it often to write code for our company. They're great at language transformations and can be trained relatively easily. So the one thing we do first is we take a corpus that we are building a search engine for. We bring in world knowledge related to the corpus in the form of text, in the form of images, in the form of structured data. We use LLMs as compilers. We digest all this and generate a database of facts. Think of the database as the same listing corpus that we start with, augmented by a lot of extra facts related to each of the listings there. And this is like a gigantic part of our processing pipeline, and one of the things that we are particularly proud of, to take a lot of knowledge here and create this database. And of course, once the chat starts, our agent starts talking to this. And of course, the core of it is a clean search experience. And one thing that we are moving toward is how do we clearly differentiate the calls to the backend search engine, and how do you conduct a conversation for world knowledge? And that is handled by this agent carefully. And of course, we bring in an LLM like ChatGPT or Bard as a call out when we want world knowledge. So for example, if you want to know something like what's the example I have? It is Geneva Avenue a quiet street? And that is something that we call out to Bard or Google or different kinds of backends. So we bring that into the conversation flow. And this is approximately how our system is architected. Of course, the part that we built so far is the core search system, and this is just the starting point of something more exciting that we're building at Tonita. And of course, this is a slide that I added hurriedly after I uploaded my deck last week because ChatGPT just said, oh, there's something called plugins, right? So in anticipation of a possible question here, I added this notion, which is that ChatGPT brings an application into a chat to augment the chat, right? Through a simple API, whatever API the developer of that application exposes. Our strategy is the complementary strategy, which is to bring conversation into a search browsing experience on an application corpus. If you go to a listing search site, any of them hopefully will power this kind of capabilities to bring world knowledge and conversation abilities to searching and browsing that corpus. Tonita understands the application corpus deeply and uses LLMs to bring the world knowledge as well as fluency as well. In particular, the search engine we built for a corpus automatically becomes a ChatGPT plugin that can talk to ChatGPT as well. Okay. The key thing people should remember is that on ChatGPT, the quality of the experience is going to depend on how good the underlying search engine is that it's calling out to, and that's something that comes out automatically in the wash when we build a search engine using our methodology. So what I've said so far is I called attention to high-level dichotomy in search, answers and decisions, and we pointed out that generative AI brings a major way to reimagine the search user experience. So far, it's a great tool for the interactive Wikipedia model of answers, and we've taken a stab at describing our architecture for the decision maker search. Of course, it's all work in progress. There's lots of evolution that's going to happen from here on out. But let me conclude with one crazier thought, right? If you look back at the web, it's been awesome at the presentation layer, right? There's so much innovation from HTML pages to JavaScript to React and Flutter and all the beauty that has happened. It's also great at transactions. You can buy tickets to an event. You can book a restaurant reservation. People have bought cars. People buy homes online. So transactionally, it's been awesome as well. But the web is not capability centric, right? But the question is, what if it were? And because of the way it evolved, publish a website, let a search engine crawl it, index it, and let people search. That paradigm has worked pretty well so far. But it is possible that with generative AI, the web can be different from how it is today. In particular, everybody builds their own, for want of a better word, I'll simply call it a chatbot, exposing the capabilities of that site or that app, and these chatbots start talking to each other. And the search engine there is a very different kind of beast. It's a routing engine. It's a decision-making engine. We're going to see all this very, very soon, maybe as, it took us about 30 years from the beginning of the web to where we are today. But getting to something like this might happen in 3 years or 5 years. We'll see. Thank you so much.